Om Sri Sairam. Welcome to the computer science class, pointers video part 3. In the last class we have seen pointers and arrays. In today's class we are going to see array of pointers and then pointers to strings. So in today's class we are going to learn how to create array of pointers, character array, then pointers to string, and how we can perform string operations using pointer. But before understanding the concept of array of pointers, let's revise the concept of pointers and arrays. In the last class what we have seen about pointers and arrays is that we have used the pointers to manipulate the array elements. To manipulate the array elements means what? To insert the elements into an array, to access the elements of the array, or if we want to perform some operations on array elements that we have performed using the pointers. But today we are going to see array of pointers. That means we are going to create an array which stores the addresses. So when we declare an array, its name is treated as a constant pointer to the first element of the array. When we declare an array means when we declare an array like this, int arr, this is the declaration of array, say array of 5. So this array name we treated it as a constant pointer to the first element of the array. Constant pointer means we cannot perform arithmetic operation on the constant pointer because the name of the array holds the address of the first element of the array, say arr of 0, address of the first element of the array it holds, and then you cannot change this one, it will always hold the address of the first element of the array. That is why you call it as a constant pointer that always holds the address of the first element of the array. This is, we also called it as a base address of the array. The 0th element is the base element, that is the starting index of an array. So that address we call it as the base address of the array. Base address is the address of the first element in the array or address of a of 0. So what is the difference between constant pointer and pointer variable? Variable, the name of the term itself explains the meaning of that particular term. Variable, just like the normal variable we know, means its contents we can change. That means suppose we declare a normal variable here, say int a, and initially we assign something 0, and then we can perform the operations like this, a plus plus or whatever any other arithmetic operation in case of integer variable. That means the contents of a we can change, that we call it as a variable. So pointer variable, when we say pointer variable, that means we can also change the contents of the pointer. What are the contents of the pointer? Address. That means if initially a pointer is pointing to some variable, say here int a is the variable and I am creating a pointer here, say star int star ptr, and initially I am assigning the address of a to this pointer, but later on I can assign the another integer variable's address to this pointer. Right now this ptr is holding the address of a. Then suppose I have another variable, say int b, so I can make the pointer ptr to point to the b. That means again I have to assign the address of b to the pointer. So the pointer variable can point to any integer variable in that program, in that scope. That's why a pointer variable, and a constant pointer which holds the address of only one, you cannot change the address assigned to that particular pointer. So we can also use pointer to access array elements, that we have done in the last class. We have seen a program also how to access the array elements using the pointer. The difference between constant pointer and the pointer variable is that the constant pointer cannot be incremented or changed. Constant pointer cannot be incremented. You must remember, means the pointer arithmetics we cannot perform on constant pointer. While the pointer to an array, once again I write a code here. Pointer to an array means, suppose here it is an array ARR5, it is an array, and int star p int is the pointer. So pointer to an array means p int, I am assigning address of the first element of a array. So this is what? Pointer to an array. This is pointer to an array which carries the address of first element of the array that may be incremented. This we can increment. That means we can make arithmetic operations on p int like this, p int plus plus, isn't it? But we cannot write like this ARR plus plus. This is okay, but we cannot write ARR plus plus. This is wrong. We cannot write because it is a constant pointer. So if pointer to an array is incremented by 1, it would point to the next element of the array. So what happens when you write p int plus plus? Initially it is pointing to the 0th element or first element which is stored at the 0th index in an array. Then if you write p int plus plus, that means we are making the pointer to point to the next element in an array. That is the advantage of pointer variable. Thus the value of the pointer would increase by the number of bytes allocated to one array element. Number of bytes allocated to one array element means, suppose this is an integer array. So each element in this integer array will be allocated 4 bytes or 2 bytes depending on which machine, whether you are using 32-bit machine or 64-bit machine. That differs from compiler to compiler and the machine to machine. So when you increment a pointer, it jump on to those many memory locations. Suppose the PTR initially the first element in an array which is at the address say 1000. First element is at 1000. So when you write PTR plus plus and that machine is consuming say 4 bytes of memory for the integer value, then it will jump on to 1004 when you write PTR plus plus, and then again when you execute the PTR plus plus, it will jump on to the next integer value, that is 1008 and so on. So the value of the pointer would increase by the number of bytes allocated to one array element. So in case of integer array, number of bytes allocated is 4 bytes. So it will always jump 4 bytes in each increment statement. Now come to our main topic of today's class, array of pointers. If you understood the mechanism that how pointer works with an array, now array of pointers. Here we are going to store the addresses in an array. That means we are going to create an array of pointers, or you can say array of addresses. As we can have arrays of integers or an array of float, similarly there can be an array of pointers. An array of pointer would be nothing but a collection of addresses. The way integer array is a collection of integers, float array is a collection of float values, character array is a collection of characters. In the same way, the array of pointer is a collection of addresses because pointer stores the address of another variable. Thus, the address present in the array of pointers can be addresses of isolated variables. Addresses of isolated variables. Isolated variables means integer variables, int a, b, c, d or float x, y, z like this, or addresses of array elements or any other addresses. That means that depends on which type of pointer you are going to create. If you are going to create integer pointer array, then it will hold the address of integer variables, or it can hold the address of another integer array. If you are going to create a pointer which points to a class object, then it will hold the address of class objects. In the same way, you can hold, that depends on what type you are going to assign while creating a pointer array. So all rules that apply to an ordinary array, that is int, char, float, double, apply to the array of pointers as well. It is nothing different. All the basic rules of array, that everything will be applicable, and it will be stored on contiguous memory locations. Same thing, because what a pointer is going to store is initially some value, but only thing is that instead of its data value, it is going to store as a address of another variable. That is only the difference. So how to create array of pointers? This way. The way we create any normal array, same way we are going to create the array of pointers. Int star p int 5. So this statement is going to create an array of pointers of 5 elements which can store the 5 addresses of another integer variables. Let us see an example. So this is an example program which illustrates the array of pointers of isolated variables. So in this program, I have created one pointer array which is of type int having size 5, and these are the 5 isolated variables, var1, var2, var3, var4 and var5, which is of type int, and to each variable I have assigned the value, integer value. Here I am going to assign the address of each isolated variable to the pointer array. So you can see at the first location in a pointer array I am going to assign, or we can say I am going to insert the address of variable 1. In the second location, that is on first index, address of variable 2, on second index, address of variable 3, on third index, address of variable 4, and on fourth index, address of variable 5. As these are the isolated variables, we have to assign individually. And then what I am going to do here is simple operation. By using a for loop, I am going to iterate through an array. Value of star p int I. What does this statement mean? We know, if you understood the pointer conventions, this is our dereferencing operator. So we are dereferencing the address which is pointed to by p int. And what does this I indicates? This I indicates the index of an array. So as I is initially initialized to 0, so the first index it will take as a 0 here, and a star p int means we are going to access the first memory location in pointer array. And what is there in the first memory location? Is the address of var1. And star means by taking that address we are going to dereference that address. That means we are going to fetch the value which is stored at that address, that is in variable 1. And then p int I. P int I means we are simply printing the value in an array. What is the value in an array? At index 0 is the address of variable 1. So this statement is printing the value of variable 1, and this one is printing the address of variable 1. In other terms, we can say that it is printing the first value in the pointer array, which is actually the address of variable 1, and it is going to print the value stored at that address, that is value which is stored in variable 1. Let's have a look. You can see the output over here, that value 20 stored at this address, value 34 stored at. So you can see this value 20 belongs to variable 1, 34 belongs to this one, and this minus 3 belongs to variable 3. So it is printing. So here it is not showing that whether we are printing the value directly from variable or by using the pointer array, we are getting the output. But from the output we can see that by using the pointer array how we can access the variable values, and these are the addresses which are in hexadecimal form. So let's look at the memory picture, which will give us the idea about this program. But before that, let's understand what this program. In this program, addresses of isolated variables, variable 1, variable 2, variable 3 and variable 5 are stored in pointer array, and dereference operator is used to access the content of the isolated variables. So for example, star pnt3 would print the value of var4, that is 8. So this is the summary of the execution of that program. Now this is the memory picture, which is very interesting to understand, because while working with the pointer we must understand that how it is going to access the memory locations. This is actually our pointer array. That means the pointer array which we have created with the statement int star p int 5. With this statement we have created this array. So this is the memory picture. What happened in this pointer array? Array means 1, 2, 3, 4, 5 locations. 5 locations we have reserved, and this represent the index, or we can call it as subscripts of the array. And what are the values? These are the values stored in this array. What are these values? These values are nothing but the addresses of variable 1, variable 2, variable 3, variable 4 and variable 5. So this contents of pointer array is the addresses of isolated variables var1 to var5, and by using this we are accessing these memory locations. So then a question may be in your mind, what about the addresses of these locations? Isn't it? Let's see that. What about the addresses of these locations? So these locations also will be having some addresses, definitely. Here, for the sake of understanding, we can see that the individual variable addresses are contiguous, but actually there is no guarantee that the individual isolated variables will be created on contiguous memory locations. But definitely the array is allocated contiguous memory locations. If we want to, we have printed the addresses of these variables var1, var2, var3, which is stored in this one. You can see here actual addresses which is in hexadecimal form, right? These are not on contiguous locations. If you can, if you remember the conversion of hexadecimal into the decimal, if you convert the number into decimal, this is 4 FED4 and this is FED0. So definitely this is not a contiguous. The another one also not contiguous. So actually the isolated variables are not created on contiguous memory locations. But if you print the address of the pointer locations, pointer array location, how you can print? You can print the address of pointer locations by just adding one statement to this program. Here we are printing the addresses which is stored in this array, but address of pointer array locations. So we can just add a simple line here, the same for loop, and we can add here cout. If you want to print addresses, so I am writing here address of pointer array. And simply what I am going to do here, address of p int of I. This statement I have to add here. So what will happen with this statement, address of p int of I? So it will print the addresses of these indexes 0, 1, 2, 3, 4 where the pointer array is created. Those addresses we can get. So you can try adding this line in this program. You can try first to execute this program, then add this line. You will get the addresses of the pointer array, means addresses of individual locations allocated to the pointer array. And this you will find that these will be contiguous. But there is no guarantee that the addresses of isolated variables will be contiguous, and we can see here they are not contiguous. They are created at different available memory locations. Now the main application of pointer is in strings. Most of the string operations are performed by using the pointers. Basically the definition of string is the character array. So instead of creating a character array, it is always a flexible practice to work with the strings by creating the pointer to an array. So strings are treated as arrays of characters that are terminated with a binary 0 character /0. So in C++, strings are treated as arrays of characters. So C++ provides two methods of declaring and initializing a string. Method 1, creating character array. So here char str1 is a character array and I am initializing with the string program. So character array is initialized like this in double quotes. We can notice here I have not mentioned the size of the array. The size of the array I have not mentioned. In case of character array, it is always a good practice not to mention the size of the array, because whatever characters you are going to insert, it will take one more byte to store the string terminator character /0. It has to be inserted. Either you insert or the compiler will automatically append at the end of the string, which indicates that this is the end of the string. So when a string is declared using an array, the compiler reserves one element longer than the number of characters in the string to accommodate null character. So you can see the length of this string is 7, 1, 2, 3, 4, 5, 6, 7. So compiler allocates 8 bytes to the str1 array. So the actual size of the str1 is 8 bytes because it needs 1 byte for the /0. Another method is declaring the character pointer. This is not a character array, this is a character pointer. So this is pointer variable and this is pointer constant. To this pointer variable we are assigning the string. So the meaning of this assignment is we are assigning the address of first character to the str2. Once again I repeat, we are assigning the address of first character to the str2. So you can see that it is equivalent to ptr2 is equal to address. Now here how you can address, because this string has no name, it is a value. So it create a unnamed string in the memory. So it is just like that. Suppose this is an character array, so it is just like that, str1 of 0, like that. So basically str2 is holding the address of p. So it creates an unnamed string in the memory and assigns the address of first character to the str2. So C++ treats string literals like other arrays and interprets a string constant as a pointer to the first character of the string. That's what I demonstrated here. This means that we can assign a string constant to a pointer that point to a char. Understand this statement. We can assign a string constant. This is a string constant. This is a string constant. So we are assigning string constant to a pointer that point to a char. So this is a character pointer. This is the meaning of this statement. Let's see a program. What happens here? This is our character array str1. So str1 always holds the address of first character. And this is our character pointer str2. So initially it is pointing to the base address 103. 103 is the base address of string constant program. And when we write str2++, then it will no longer hold the base address, it is pointing to the next character, that 104. So that's why when you execute a program, you can see here, this is a program where I have created the character array and initialized it with the program, and I have created a character pointer and assigned a string constant to the str2, and I am printing str1, str2. So the output of str1 here is same program because we stored the program, and the str2 also printing the program, which is actually different strings. These are the characters stored in character array, and this is a string constant. The values are different, and then I am performing some arithmetic on character pointer. This is a character pointer or pointer variable to a character. Better way, I write here the pointer variable, which is of type char. Pointer variable which is of type char. If we use the terminology pointer variable, that means it can change. This is pointer constant. Array name is always a pointer constant. So we can increment it as we are increment it is, so increment str2 and skip character p. So this is after that I am printing the value of str2 here, cout str2. So you can see this is the output. After printing because now I have incremented, that means I have moved the pointer from first character to the second character. So it is not printing the p, it is printing from r. First character it is skipping, and this I have commented here that str1 plus plus. If you are not able to see str1 plus plus, this I have commented here because if we write str1 plus plus, which is a constant, then you will get an error. Compiler will give you an error. What is this error? You can read this. Deprecated conversion from string constant. So it is clearly mentioning that this is a string constant to character pointer. We cannot convert a string constant to a character pointer. This is the error compiler is giving us, right? Because str1 is the base address and it is a constant. We cannot increment it. So I have commented. That's why then we can execute a program. Hope all of you have understood this program very well. So these things you just have to understand here. Simply these two things, that here one point that we can increment the pointer variable, but we cannot increment the pointer constant. So character pointer is a pointer constant. Now this is an implementation or the example program to find the length of the string. Most of the string operations are performed and it is very flexible to perform the operations on string using a pointer. So this is a program which displays the length of a string. Let's understand this program. In this program I have created one character array and one character pointer variable. Again, throughout the class I will use the character pointer variable so that you can understand, we can change it. And now I am asking to input a string. Used the getLine function to input a string. Those who have not studied this IO library correctly, I will explain this function. str, it is the destination where we are going to enter the string. When the program will be executed, we are going to enter a string in str. So this str array name I am giving here, and 20 means I am instructing that 20 characters I have to input when this program will be executed. Now I am just printing a statement that display string using an array variable, and string is str. So here simply this is the simple convention to print the array contents. Now here pstr is equal to str. What is pstr? Character pointer variable. And what is str? It is a constant, character pointer constant, or character pointer constant, or character constant pointer. Anyway you can call it. This is assignment, means assign base address to a pointer, assigning the base address to a pointer. So here we don't have to use the address of operator. Don't make a mistake, because you may be having a concept in a mind that whenever you want to allocate an address to a pointer variable, you have to use the ampersand sign. No, because it is same as we are copying the contents of one integer variable to the another integer variable. What we do here? Integer a, okay, which is 10, and another integer variable, say integer b, which is nothing. So what I am doing here, b is equal to a. As b is also a integer variable, a is also a integer variable, so I can copy the contents of a into b, simple way. So here pstr is also a pointer and str is also a pointer. So pstr can hold the address, str is already holding the address of the base element of an array, so we don't need to use the ampersand sign here. So just assign the address in this way. Now I am going to print the string, as well as I am going to count the number of characters in that particular string. So while loop I am using here star pstr not equal to /0. That means I am going to move the pointer until I don't encounter the /0 character, which is the end of the string. Star pstr means here I am printing the characters in the character array, and pstr plus plus. So this is what, this is I am incrementing the counter pointer from first character to second. So this will print first character, because pstr initially it is holding the address of first character in an array. So first character will be printed, then I am incrementing the pointer, it will go to the next character, then again it will print the next character. This way I am printing the whole string here, programming. And then the length of the string I am going to print here. So length of the string is pstr minus str. This way I am going to print the length of the string. So this may be something surprising for you, but you will understand the logic in the next slide. See, pstr minus str. So here, to understand the logic, what we will do, pro graming and then /0. So this is an array. I am writing the index locations here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So there are 11 index locations, means there are 12 characters here. So actual the size of array is 12. Now the first one is the str. our str, say here the addresses are like this: 1000, then 1001, 1002 up to 3, 4, 5, 6, 7, 8, 9, 10, 11, 1011. So these are the addresses. Consider these are the addresses. So initially str is pointing to the 1000. So the content of str is 1000, and initially we are making the pstr also pointing to the first. This is the pstr pointing to the first one with the assignment statement pstr is equal to str. This way pstr is also pointing to the first location. But with the pstr plus plus, what is happening? It is pointing to here, then here, then here, and here, there, and then at the end pstr will point to here. So the final contents of pstr is 1011. The initial contents of str is 1000. The final contents of pstr is 1011. And the statement that which we wrote pstr minus str, that means 1011 minus 1000. What will be the output value? It will be 11. So this is the length of the string. So we are actually calculating the difference between the address value of the initial character as well as with the final character. So till the end of the program, str is always holding the base address, but pstr is going on incrementing, jumping on to the next character and reaches to the last character. So the last final value held by the pstr is 1011, and str still holding the initial value. So that's why we have made use of this logic and simply subtracting the value of str from pstr, which gives us the 11, which is the length of the string. So this is the simple application of pointer array to manipulate a string. There are other more applications also. Suppose you want to append a string, you want to print a string character, or you want to perform some another string operations, you want to change the strings from uppercase to lowercase, from lowercase to uppercase. So many string operations we can perform. So pointer helps us to perform these operations efficiently. Hope all of you understood this concept very well. Let's revise once again what I have taught you today. Initially you have to revise the concept of arrays and pointers, which is a simple one, and then we have seen the pointer array. So pointer array is simple, nothing but storing the addresses of other variables or storing the addresses of other array. That example also I would like to give here, that how we can store the addresses of other array. So one simple program we will try to write here. Suppose here I am creating is a main function, and I am creating an array, say integer number, and which stores say 3 values, simple values, say 5, 10 and 15. This is a simple, and one pointer I am going to create numptr, and here nothing, okay, sorry, numptr whose size is also 3. That means numptr is a pointer array and num is the integer array. This is a pointer array and this is integer array. What I want to do is that I want to store the address of these array elements to the pointer array. How I can do is very simple way. If I use a for loop for int I equal to 0, I less than 3, I plus plus, then numptr. In numptr, what I am going to do, address of num of I. So what it will do? It will assign the address of 0th element first to the num ptr, then next time it will one more modification I have to do here, that instead of this one I am erasing this, num, as it is an array, num ptr of I is equal to address of num of I. This way I am going to assign, because this is also an array. So this should not be here, this should be here. So num ptr of I is equal to address of num of I. So here in memory we have created 3 arrays. One is the num array, this is the num array which stores the value 5, 10 and 15. And another array, that is num ptr, so which stores the address of this one. So suppose address of this one is say 100, then this is 104 and this is 108. So these addresses I am going to store here 100, 104 and 108. This is num ptr. So both are the arrays and the assignment is like this. So don't confuse here that how we are using the address, because address operator we have to use because num stores only address of initial element, base address, but we want to assign the addresses of other elements also. That's why address of num of I. You cannot write like this, address of num simply. You cannot write like this, but this is the correct way. This will assign the address of each individual array element to the pointer array. Hope all of you understood this topic very well. So execute the programs which are given in the book and try to make some modifications in the programs which I have taken here, then you can understand and clarify your concepts very well. Thank you. Sai Ram.